I was recently shopping online for massage guns, which are for massaging sore muscles, and I noticed that one of the popular ones, the HyperVolt, here's a Google search for it, it sells for about $300 to $400, and I was a little suspicious of the price just because this is basically a reciprocating saw with a blunt end, right? It needs to hammer your muscles, and the purpose is for myofascial release. It helps reduce soreness, increase flexibility. So I was thinking maybe it was possible to find the same product without the HyperVolt labeling from the factory for much cheaper. So did some looking around and I found this model from Apollo Kinetics. I'm going to show you a teardown today, and we're going to try to figure out if it's the same as the HyperVolt. So this is the package it comes in. It's very similarly advertised, and a lot of these product shots look the same. So it comes in a zipper case, and we open up the case, and we have the massage gun and the attachments. And typically there's some kind of ball attachment. This one has some cat hair on it from being in the house with our two cats. This one's for your spinal cord. It's supposed to massage on either side of your spine. This one is supposed to be the flat version, but it has little nubs. And then there's this one that's like a pinpoint. So this thing also comes with a charger in the case here. Pretty beefy charger. This one is rated 25 volts at 1 amp. So about a 25 watt charger if it lives up to its claims. And we also get a user guide, and we get some extra rubber O-ring sort of washer things to put on these attachments to keep them from slipping out. They just press fit in. We'll go over that in a minute. But so let's just take a look at this product from the outside before we open it. And I want to call attention to some of the things I was looking at to see if this is indeed the same product, or if we suspect it's from the same factory as the HyperVolt. So this one, I'll note, only cost about $80 shipped from Amazon, where, like I said, the HyperVolt was going for about $300. And I want to call attention to sort of how to compare these products when you're looking for the option of buying what's usually a white labeled product from the factory directly. So, the way these are usually produced is a company will spend the money doing the R&D, developing the product, and depending on how generic the product is, how much of a commodity it is, usually the factory that figures out how to make it will sell it with the option of branding it differently for different companies. So this same product might be sold under many different brand names. You can put your own label on it, hence the name white labeling, and underneath is the same product, generally just repackaged with slight cosmetic differences. So typically when we want to evaluate one of these for whether it comes from the same factory, I look at the things that are most expensive to change. So start by looking at the overall shape of the products. These things look very similar. The HyperVolt, which I don't have, didn't want to spend the $300, but the HyperVolt and the Apollo Kinetics models both have the same general layout. There's a handle with a prominent ring around the bottom. This ring does light up. I'll show you in a minute. There's some kind of latch button on the side. The details of this molding are a little bit different, but the layout is the same, which means that inside is probably the same mechanism. And the insides are more expensive to change. It's easier to just rebrand the outside. So typically you will see small differences in the trim when these products are white labeled. That doesn't mean they are not the same product. This might just be a variant of the outside plastic. Well, notice there's two screw covers here, same two screw cover positions on the Apollo Kinetics. The chuck looks very similar. This one on the HyperVolt has a little bit smaller grip knurling than the Apollo Kinetics one. But they both have sort of an alignment notch at the top. If I push this, let's see if I can find it. Actually, this one doesn't have it. So here I'm looking at the outside ring plastic here. This one has a notch at the top. This one doesn't. So I thought I'd seen one, but they do both have this tab at the bottom. I don't know if you can see that in this photo. Let's see if I can zoom in here. So at the bottom here, where the inner ring meets the outer molding, there's a little tab for alignment. This Apollo Kinetics one has the same thing. Obviously they're branded differently. The top trim has a slightly different vent pattern, but again, this is the outside case. It'd be pretty easy to order one of these with a different molding design. And if we look at other photos of the HyperVolt, one thing in particular that I was looking at was this back control panel. Oops, just lost my search result. Pull this up again. Something is not working about the iPad. All right, well, it's not loading. All right, here's a good photo of the back. So if we look at this photo of the control surface, these photos don't, like the photos of these products don't always show the controls, which are usually on the back grill. But I do notice that these are very similar. So there's like a circular hole pattern. This one has no branding on the back, the Apollo, but the HyperVolt has the Hyper Ice. I assume that's how you say that. Hyper Ice branding. It does have red and green LEDs in the same arrangement. And it has some blue LEDs along the top. And there's this power button in the middle. So these two grills look cosmetically quite similar, despite the branding differences. I'm suspecting that the control circuitry in here is the same. So if it's true, it might be possible to get something very much like the HyperVolt with different branding for basically less than a third of the price, which would be pretty awesome. So I suspect my network is on the fritz here because of recent installation of a Pi-hole ad blocker. But we're done with the iPad now. We've looked at the photos. You can look at other things like the design of the battery. The battery does have this light ring on the bottom when you turn it on. And all these batteries are the same design. There's sort of a rubberized cylinder. There's a ring of light. There's a switch on the bottom. And this one is branded Apollo Kinetics as well. But based on this model number, we can see it's an 18650 battery. I don't know what the 2000 is, probably something, 2000 milliamp hours. So don't know if that's true, but these batteries generally always look the same across these products. So I suspect they're using the same tools, the same factory potentially. It might be the same product. And I want to take it apart to see some of the claims are true. So they claim this one has a brushless motor. And from the sort of cutaway photos I've seen, the brushless motor is somewhere up here. And this battery is removable. So I will show how that works. There's this tab here that presses on a release tab in the body of the case. And it's pretty hard to push. I think from what I've seen, you kind of have to wiggle it, pushing on it with quite a bit of force, and then the battery will slide out. So this battery it's nice that it's replaceable. If you have one of these and you want to use it in like a class setting, like a therapy class, you might need to swap out the battery because it takes a while to charge. This battery is a pretty generic item. It'll probably work across all of these different, similarly white labeled versions of this massager, but I haven't confirmed that. And it has a positive and negative and some kind of contact on the front. Not sure what that contact is for yet. And then this tab on the side that releases the battery is what this button presses on. So the battery on its own is pretty cool. It lights up when you turn it on. You can turn it off. That controls the output to the terminals. Presumably, that'd be something that'd be good to check. And this one has a rubberized grip wrapped around it. So it's a pretty solid battery. This battery forms the handle of the tool. It's a quite large diameter. If you have small hands, I don't know how comfortable it'll feel to hold, but they did fit a lot of battery power in here. All right, so onto the body of the tool. So this one is in a rubberized gray finish, and you can see where they spray painted it. The inside is still the sort of puke brown ABS color. And the spray, they don't need to spray the inside here, but you can see some of the overspray from the coating. This one feels really nice to the touch. So we're going to take it apart. First, we notice there are 4 screw covers here, so we can pop out these rubber molded covers, put them aside, and some of these are lined up better than others. I'm going to see if I can pull these out without a spudger, but it might be helpful to have a tool. Let me grab one. All right, so I've got a fiberglass spudger here. Just going to use it to gently remove these rubber covers, trying not to scratch the outer coating of this. I don't intend to destroy this one because we are using it. If I destroy it, I'm on the hook for buying another one. So I'm being careful, including with the way it looks. Just going to pop out these covers. The perils of having no fingernails. All right, 3 of 4. I ditched the spudger idea because it's not quite a fine enough tip to reach down in there. I could, of course, try flathead screwdriver, being careful not to mar the case. Reach down beside this. Oh, perfect. Okay, pops right out. And of course, it is on the floor. So set this down. It'll sort of roll away if you basically balances though. All right, one of the rubber guards is on the floor and we will find it later. All right, so you can see some labeling on the inside of the case here. It says Apollo Kinetics Pulse Portable Massager. DC in 24 volts at 1 amp. So interestingly, that's the same power rating as the charger, but unfortunately I did try, you can't run this while it's charging. As soon as you plug it in, the battery turns off. So I don't know if that's to protect the power supply in case it's not really rated for this current or something else, but it would have been nice, I think, to be able to run it while it's plugged in, but it doesn't seem like that's possible, at least with this model. So let's take out the screws and see what's going on in here. So you'll notice this is a 2-part construction. There's a top shell, a bottom shell. These screws holding the shells together, and then this rear cap has a screw retaining it. And it's possible that the rear plastic is holding the back together. I'm not exactly sure. I don't see any screws down here in the battery well. So let's go ahead and take out these 4 screws. Need a smaller screwdriver, of course. And I did look at, when I was searching for these, I searched on Banggood and AliExpress and Alibaba, the usual suspects, for other white labeled versions of the same product. And I saw a few, but generally they were only marginally cheaper than this one. This one, again, was like $80 with free shipping. And ordering the ones, the cheapest one I saw that looked like the same product based on the mold lines, the claimed frequency, the battery size, things like that. Looked like it was going to be about $66, and then plus some shipping, and then a very long shipping time from mainland China. So this one was a pretty good deal in comparison. Something like 4-day shipping within the US. Okay, so unfortunately, small screwdriver comes with a small handle, which means torque is not so good. So I suspect what's going on in here, based on the pictures I've seen of, the inside, which are largely marketing, sort of contain like lots of blue and green electricity signs, flowing currents. It looks like the motor is somewhere up here, and I do see something rotating in here when it's running. I forgot to show what this is like when it's running. Hopefully we will be able to put it back together and then turn it on. Then we will have succeeded. But yeah, basically we're expecting the motor to be up here, and I think what's happening is just there's probably a reciprocating arm here and connected via linkage to the motor. So probably very simple, same way a reciprocating saw would work. I've seen some people online cobble these together out of jigsaws or other power tools. Be careful, obviously, if you do that. Okay, so taking out the back screw. These are just screwed directly into the plastic. It looks like there's no mitigation for vibration, but they don't really need it because the plastic is very accommodating. So I'm pulling off this back cap, and it comes with the circuit board. We can look down in here, and we can already see, interestingly, we can see the what looks like part of the linkage just in here with the wires. So if I move the end of the tool, you can see the linkage sort of moving in here. It's interesting to me that these are just in the same cavity as the wires. As long as the wires are out of the way, that's fine. But you don't really want to snag those in the running mechanism. The bottom of the case pops off really easily, with the caveat that the wires are still attached to the battery terminals. And here we see the mechanism. So turns out this is a very simple device. I'm pleasantly surprised. I was not expecting a metal link arm here. We have some real skateboard bearings, looks like. I don't see a number on there. So that is a 608 RS. So standard skateboard bearing, as far as I remember. It's been a while since I skateboarded. Excellent to see. And then this looks like a machined aluminum arm, a little bit crunchy machining, but it doesn't matter. You can't see it. And that drives this tool end. And it looks like the other end, this end looks like we might have a bushing rather than a bearing. I'm not exactly sure. But this is very nice to see metal construction. But also, is this worth $300? I would suspect not. So let's try to take out this cable. It looks like they've tied up the cable loom, the wiring harness here to keep it out of the way of the motor, potentially. Shorten it a little bit. Just gonna unplug this connector, if I can do it. Connector has a little latch on it, which is great for vibration mitigation. And then if we look at this board, this actually looks like a pretty nice motor controller board. Let me make sure this is focused. So here you can see, I don't know if you can see this rotor moving in the background. The motor probably has so it's a brushless motor, which means typically the stator is active. So the windings will be in the center of the motor, and then the permanent magnet will rotate on the outside. So likely it's just like a large version of a computer fan motor. There will be a control board in the center feeding the windings with its sensing circuitry. And then on the outside, we just have a large sort of sheet of permanent magnet wrapped around a metal casing. In addition, you see on this, the plastic mounting points, we have some more vibration mitigation in the form of these rubber gaskets. And I don't know what kind of plastic this is. Maybe it's labeled somewhere. I don't see any mold markings currently. So let's keep going. I think to take this apart further, there's a few options. One, I could try to find a position so it looks like no matter where this is rotating, the link arm doesn't come all the way out. So we could try detaching the screw from the motor, the drive shaft, or we could try removing it from this end. I'm not sure. My fear is that I'm going to break some thread locking and then it'll be hard to get this back together. But let's try taking this screw out first. Okay. And I'm just being cautious because I am on the hook for buying a new one if I can't get this one back together. So obviously the motor's going to rotate with this screw. It would be nice to keep these things mated together. I'm also seeing a set screw down here on the side of the cam that comes out of the motor. I'm not sure if it's retaining this screw on top. So I'm considering taking apart this end. Let's just try lifting the whole assembly out. So I'm going to take out these Phillips screws. Okay, these have nice big pan heads to squish down those rubber gaskets. Overall, very pleasantly surprised by the quality in here. I was expecting a plastic link arm with maybe some glass fiber in it, maybe not even. For the price, this is pretty impressive. Drop a screw in there. And it looks like this motor control board is very tidy, so it'll be interesting to take a look at whether that's just an off-the-shelf part. I suspect that it is. Okay, screws are out of the motor mount, and I haven't taken apart any of the linkage, and it would be very nice to leave it together. So let's just see if we can lift this out a little bit. I don't know what's retaining the sort of piston at this end. If it's very tightly constrained, we might not be able to rotate this enough to get it out of here. But if there's some slop, we might be able to angle this up and slide the whole assembly out. So let's see if we can't pop this motor mount off of these brackets. off frame here. Zoom back out. Okay, so I don't want to push this too much at an angle, but I'm not even really convinced that it started lifting out. Here we go. See if I can grab this. Okay, so it is bending a little, but it doesn't feel like it's coming very easily. So we might need to loosen off one of these fasteners. I don't see any retaining set screw in here. I'm inclined to take this fastener out next. So let's give it a try. Find a hex wrench that's appropriate for that one. Perhaps this one will work. Good luck if you get it on the first try. All right, so this might be, I have an Imperial hex wrench here, probably a metric fastener, but let's see if we can get close enough. It's a little wiggly. He says continuing. Okay, great. So it's starting to loosen off. I'm not going to strip it. I'm not putting on too much force. Ooh, nice bolt. Okay, so here we have a nice machine screw. There's a split lock washer on here, and then underneath that there was this copper, looks like a copper bushing, copper washer, probably just to allow this to rotate. And then underneath that, awesome, there is a actual bearing, and actually that copper might be like a little bearing shroud. Let's see, being careful, there might be another piece of copper underneath. I don't see one though. So now these two pieces are free. I'm going to slide the tool holder out the end. This is a little greasy from the factory. The grease does come off if you aren't careful, so you might want to wipe this off when you first get it. This feels a lot like magnesium. It's very lightweight. It has sort of that dull orange luster. Interesting choice of material for this piece. I don't have solvents to test it, and I don't really want to dissolve it, but could do an assay to see what that's made of. You can see there's sort of like a Teflon-looking ring around where that piston fits in, and then we can pop this piece out, hopefully, now that it's detached. Awesome. Okay, so very heavy motor. Feels awesome, and then here we have the top housing. So I could keep going. I could take out these 3 screws. Presumably they hold this sort of decorative plastic bezel in here, and that plastic bezel seems to be retaining the Teflon cylinder that the piston goes in. So you could replace that piece if you needed to, if it got really worn out. It'd probably be time to replace the tool anyway. I don't think I need to take the plastic all the way apart because we kind of can guess what's in there. But this is the top of the mold. Ooh, and some split ring washers dropped out. Always exciting. So we'll review the footage and see if we can figure out where those came from. I have no idea. All right, so let's look at one suspect would be they were retaining the screws on the motor mount. But I don't really see evidence of them on here either. So we'll have to take a look at the footage and see if we can spot the locking washers before they fall out of the mechanism. So I didn't end up loosening the screw off. It's still attached to the motor. This motor has a little counterbalanced output here. Like the cam has a counterweight on it, which is interesting. Nice to mitigate some of the vibration. We can see here, like I said before, this says the product code on it says BL50250-002 16.3 or 16.8 volt DC. And then we have some presumably more product code, I'm not sure, 200320F1. So the BL suggests this is actually a brushless motor. Again, based on the looks of it, it has just a permanent magnet in the rotor and an active stator in the middle. And I can even look under, if you can see, I don't know if you can see that, probably not. I can see little windings underneath the rotor. So very cool, real brushless motor like they actually advertise. Sometimes those things might be just made up. This arm looks a little funny that the screws stick out of the part underneath. Like the screw heads are a little wider than the part, but hey, this is retaining the bearing. So, you know, if it works, it works. I presume that the bearing is sitting on a little lip. Yes, on the underside. So to take this apart, you could take the center screw out if you can hold the motor still. I assume there's some thread locker on there. There was some blue thread locker on the screw on this end. And then you could take these two screws out and the bearing would lift out of this link arm. That would allow you to replace the bearing. And it looks like the front one is just sort of sitting on a ledge. The bottom of the part has a smaller through hole. So, and then you can see where the arm has been narrowed a little bit to pass over the linkage here. So it can sit relatively centered. So overall, neat little mechanism, very simple. I like these rubber mounting gaskets. I'm not going to take apart the motor any further, but one cool thing I'm noticing is that the connector on the motor board, it has labels. So we see there's PWM, what it looks like it says DGN, then FR, FG, and VBB. So presumably it's PWM controllable for speed. I also noticed that this board, you can see that it's kind of shiny. There's a blue tint over the soldered connections. So this board is conformally coated to presumably to prevent the ingress of moisture or metallic particles that might short out the circuit board. Let's see, anything else of note here? FRFG. It'd be interesting to know what those labels mean. I don't have any guesses at the moment. All right, so there's the motor assembly. Very cool, nice little brushless motor. This might be useful for other projects. It would be interesting to look up this part number later to see if we can find this unit. It's a solid motor, and supposedly, according to the documentation, there's like a 70-pound stall force on the sort of linear actuator end. Like if you hold this against your body with more than 70 pounds of force, it will stall it. But that's a pretty impressive capacity for a motor of this size, if it's true. Okay, so let's move on to the bottom half of the shell. So this is just we have our control board. There's a speed control. If you press the button multiple times, the speed will cycle through low, medium, high, and then power off. So presumably, if the motor PWM pin does actually accept PWM input, which is pulse width modulation, to vary the speed, this board probably has a microcontroller on it to provide that PWM signal and vary the speed of the motor. We have here the battery receptacle for this classic massage gun battery module. So pretty cool. They just put a sticker on it to brand it differently. I guess this component was made specifically for this kind of unit, but I've never seen this battery in other products. Maybe it's commonly available for other products like this one. I'm not sure. Another cool thing I'm noticing is that they have staked these wires down with a little bit of adhesive, some kind of like silicone or otherwise flexible epoxy. That's nice to keep them out of the way of the moving linkages, which are right above this, and also just limit the chance of that intense vibration wiggling the wires loose. And then on the backboard, these connectors are actually epoxied in place as well, or with some kind of adhesive or silicone coating. Let's take this board out just to take a look at it, because you can see a little bit of circuitry on it from the front. I'm not going to take the connectors off because I don't see a need to. If you were repairing this, you could rip that epoxy off of there, whatever, the adhesive, and take the connectors out, and you could swap this circuit board for another one. I don't know if these are easy to find. Circuit board has some labeling on it that we can take a look at as well. Get these screws out of here. Every time we take out a screw, there's a little bit of plastic dust, which is kind of gross. feels kind of like polypropylene, but usually these kinds of things would be made from ABS, and so I'm not exactly sure. You can sniff it, can't quite tell. Okay, so taking the control circuit out of the back grill, this grill is, very full of holes, presumed for ventilation. I suppose there's a little ventilation possibility from air passing through the case, but the motor, one interesting thing, unlike typical power tools with a motor around this size, there's no active like fan-shaped piece of a rotor. There's no separate fan, so this isn't going to do much to encourage airflow through the unit, except by the oscillation of this arm. So this will allow a little of air to pass through, but there's not really any active cooling here. Let's see, what else do we see about this? Looking at the molding inside here. The little power button is sort of rubberized. You can see that there. Feels like a piece of molded silicone. It just sits in here between two retaining tabs. And otherwise, I'm just noticing you can see some of the machining marks on the mold in here, but I don't think that indicates that this plastic has any fiber in it, any glass fiber. I'm not exactly sure by the look of it. Again, it doesn't have any mold markers to indicate the type of material. Feels reasonably tough, but again, this is just a cosmetic cover anyway. So this rubber button just floats in here freely. It presses on the micro switch. Zoom in here on this circuit board. So let's take a look at the circuit board. So I'm gonna try to look at U2 here, the tiny microcontroller, presumably. Let me take a look off camera, see if it has any text we can read. Oh man, it is small text. Says, looks like it says SC82F7 251M. Can you all see? Let's see if I can get that on camera in case you all want to do your own reverse engineering. The camera doesn't like focusing quite that close. I'll take a photo of it and put it up in a moment. Meanwhile, we can see there are some, as is typical with this kind of board, there's some unpopulated component spots on here. There's space for, obviously, the LEDs. They're labeled D1 through D5, and their directions are marked on here. These are on little plastic standoffs. So these LEDs are to indicate the battery level. So presumably this circuit board gets some kind of either report from the battery about the battery's current charge level, or the circuit board has its own battery health monitor in it, though the battery can charge itself. So I suspect that most of that stuff is in the battery module. And then we have these lights at the top, the blue LEDs, to indicate the level of like the current setting. And obviously we have our momentary push button in the middle. There's some space for 3 additional LEDs, presumably LEDs that aren't populated. Don't know what those are for. And presumably a microcontroller. And then we have a resistor network, probably going to the inputs of the LEDs from the legs of the microcontroller. Probably most of these pins on the microcontroller are dedicated to driving the LEDs. But we do handily, it's just very tidy because we have labels on the connector on the output of this circuit board as well. So we can see which pins correspond to the pins on the motor. So these say PWM minus, the minus is turned sideways though, so it looks like a 1. F/R, FG, and plus. So I do not know what F/R and FG would mean, but PWM minus and plus, presumably for power. Let's take a look at this one again. So DGN and VBB were the power cables on here. So DGN could stand for something like dark green if we're unlucky. On here though, I don't think it does. So these pins typically, they look like they're labeled for the purpose instead of the color of the wiring loom. So here could be some kind of negative, and then VBB might be the voltage of the battery power. Not exactly sure why they'd be called those things. but the PWM is on one side, and then the VBB corresponds with plus, so that makes sense. DGN corresponds with minus, so I'm presuming that's the supply negative. So this motor would be possible to hook up to something else probably. This circuit board is labeled Bach Tech, and we get a little, some kind of a logo on here. It looks like, I have no idea, maybe a dragon in profile, can't quite tell what that is. And we have BCMG, so Con 001. Oh, this is a label for a connector. So, and this is dated 2019-07-03, so fairly recent revision of this circuit board. Right now it is July of 2020. So this product was manufactured last year, which is also a little bit surprising. I would expect there to be a large stockpile of these control boards, but maybe this is a fairly recent one. So all in all, it's a very simple product. You know, it's a brushless motor, which is pretty cool, although it's not really necessary. You know, this could have had a brushed motor just as easily and it would have worked fine. But a brushless motor and a microcontroller to send it a PWM signal, we can do a reverse engineering of this circuit. And then the beefy battery unit, which I'm not going to take apart in this video because lithium batteries are pretty scary, and I don't see any fasteners on this one, so probably going to have to take off some labels to get it open, and perhaps even break it open if there are clips. But I can say, as a result of this investigation, that it does seem to live up to its claims. It has a brushless motor. It looks exactly like the same mold lines as the HyperVolt. They don't say this is the same as the HyperVolt, but this control circuitry looks like it's branded by a completely different party. It'd be interesting to know if this is the same control module that we find in the other versions of this product. But I'm pleasantly surprised by the metal linkage, and I've used it a few times. It works great. So let's put it back together. We can turn it on, take a look at how it runs. I suspect that this is the exact same product as the $300 competitor, but awesome to take a look at. So let's get back to putting it back together. We did lose 2 lock ring washers in the process of taking it apart, and I don't actually see where those came from. So the first order of business will be to mount this control board back on the back panel. Don't need the washers yet, but when we get to that part of the reassembly, I'm going to look at the video, so I'll have to pause and see if I can see where they fell out of the case. So let's line up these LEDs. We have the blue 3 LEDs at the top. You can kind of see the bigger holes where they go. And I'm just kind of lining them all up. And let's grab the screws for this guy. Of course, going to drop one, so get a small screwdriver. Stick these back in. And the motor controller is integrated with the motor in this unit. So presumably this control board on the back is just managing a PWM signal for the motor. So that means in theory you could swap out this control board. If something were wrong with your power button, you can of course replace the micro switch on here, but it also means you could ostensibly put in a different microcontroller. You could program a different PWM profile in. You could maybe even oscillate the speed of the motor by varying the signal over time. You could have potentially more aggressive modes. I don't know if this one is actually turning up all the way to like full saturation of the PWM signal. So it's possible that you could sort of overclock this if you are able to put in a PWM signal at 100% duty cycle, if this one isn't putting out 100% duty cycle. But beyond that, I don't know if there's any exciting opportunities for hacking, because fundamentally this is a a stick attached to a motor. So it's kind of, I don't know if there are that many possibilities for improvement on the innards. So I'm going to slide this connector back. One cool thing is that they didn't epoxy this motor connector in. So it is possible to do this teardown without breaking any of the epoxy. The motor controller is pretty self-contained, and it looks like it has there's actually a lot of circuitry on there. It'd be interesting to do a teardown of that one in a future video. It would require taking off the linkage here and then taking off this plate, which is covering the circuit board. And it looks like, I'm just looking under the edge here, there are a lot of components on that board. It looks like it's a pretty well designed, tidy little circuit board. And in theory, like if this thing stops working, I would suspect that something on the motor controller board has gone wrong, assuming the battery's still good, because this motor controller board is going to contain all the active power switching components that take in the PWM signal, amplify it, turn it into a motor control signal. So if something goes wrong, I suspect you have to replace this whole motor unit unless you can find the circuit board that goes with it. But it looks like the conformal coating from the circuit board is also covering some of these pieces of metal, so it might all be kind of stuck together and difficult to extricate. Okay, so let's see if we can get this back together. First of all, we want it to be right side up. And I don't see any, let's see if there are any registration marks on here. There are a few. We're going to put the cap on later, so I don't have to worry about that quite yet. The motor clearly goes, he says, clearly forgetting how it goes in. Let's see. It goes in the other part of the case. Wow, need to work on my short-term memory. So if you'll remember when we took this out, the last thing I did was I took the motor mounts off, and then before that I took the linkage apart. So I'm going to put the motor back in first, and this cable was already knotted like this. I'll leave it like that, and I'm a little concerned about these split ring washers. So I'm going to pause the video, take a look at where they might have been attached. We already have the one on this screw that goes at the end of the linkage to hold the attachment. So this one comes with a split ring washer and a little copper, like bushing kind of washer. So I'm gonna pause and take a look. I'll be right back. And we're back. So reviewing the footage, I did find where the split ring washers were, and it makes no sense to me. So this motor board is on these gaskets to keep it from vibrating, and for some reason there are these split ring lock washers on these posts in the case, and I have no idea why they would be there. The screws holding this in are cinched down against the rubber gaskets, so it's really going to keep them from vibrating, and the lock washer underneath the rubber gasket isn't really going to, it has nothing to compress against. I guess it has a split, so it can't rotate against these molded pieces of plastic, the little fins, but that does not really make sense to me. You can see the screw hole here missed the center a little bit. I wonder if these are drilled by hand. It kind of suggests that they are, but okay, so I'm gonna put those washers back in for the sake of completeness, but I don't expect that they do anything, and it would not be a problem to leave them out. So now we can go ahead and tuck the motor back in here with these screws. I'm gonna put them all in loosely, make sure it's aligned, and then I can tighten them all down. Oof. Can see the fumbling of the screwdriver. Okay. Don't think, obviously the this is a rotating motor, so the alignment in this plane doesn't really matter, whether this is rotated a slight bit, but it does matter that it's flat, relatively flat, so that it's parallel with the motion of the end effector. So just make sure it's seated all the way, putting it in, which should be accomplished by tightening the screws. All right, so I'm gonna bring in a bigger screwdriver here, just tighten these down, make sure everything's seated well. This one is still very loose. And you don't wanna totally crush it because the gaskets should have a little play, but you want it to be pretty tight. This one actually feels, I'm a little sketched out because this screw feels like it's not tightening as, oh, there it goes, okay. So I can get pretty tight. When I opened the case, I noticed that these were fairly compressed, so I'm gonna do the same. You don't wanna like crush them into oblivion, but you do want the screws to be pretty tight so they don't wiggle loose. And tightening the screws results in a more compressed gasket, which means its spring constant is higher, so it'll damp these smaller vibrations. It won't damp the larger vibrations as much. They'll have better high frequency characteristics, potentially. I have not confirmed that, so check my facts. But okay, so this feels pretty good. That one's the tightest, just making sure this is uniform. Obviously spending more time than I need to on this, but I don't want to have to open it up and fix it, so it's worth getting this right. Okay, so round robin is finished. Everything feels good. And let's go ahead and put the end effector back on. So this is the greasy part. I'm not gonna put more grease on it. I don't think it really needs any. I'm gonna try to keep the grease out of the middle where it needs to hold the parts in by friction. And obviously the screw goes in here from the top, and the receptacle is threaded in the end effector piece. So this screw, if it came apart from its accessories, you can put them back together, but it has a split ring lock washer underneath the head, and then it has a copper, seemingly a copper, something like maybe it's oilite bronze or something, some kind of bushing kind of piece underneath the lock washer. Maybe just to shield the bearing. And I used the wrong wrench to take this apart. This is an Imperial hex wrench, and this is a metric fastener, which you kind of would expect, but I'm just not going to crank on it too hard, and I won't strip it. So this can be snug, but it doesn't have to be too tight. And if you're worried about it coming loose again, you can put more Loctite on. Like I said, it had blue Loctite on it. I'm not going to worry about that right now. But so we want to make sure it has a very small angular deflection. So I'm actually surprised they went to the trouble of putting a ball bearing on this side. They could have used just a bushing, probably, for such a small angle. So it's actually kind of nice. This is pretty tight. I'm not going to tighten any further. You want to make sure it's still free to move. Obviously, you don't want this to be totally crushed and seized up, so don't over-tighten screws holding bearings. Okay, so we have the top of the case reassembled. Sanity check here. The motor cable is reinstalled, and obviously things are lined up. They only kind of really go in one way if you keep this cable loom out the back. I guess you could install the motor backwards, but it really wouldn't be the end of the world, except the cable wouldn't reach the control board. So we can put the shell back together. Got a little oil on it, which I can wipe off. And this rubberized plastic, it feels really good right now. I have had products with this sort of rubberized plastic degrade after a while because the rubber sort of changes. And one other thing I'm noticing here is that this little back end cap is quite clever. It has a little channel that allows you to rotate it to lock it in. So you put it on maybe at a slight offset from the screw hole, and then you turn it, and that locks it on. And the screw is actually just to keep it from spinning. So that's quite elegant because it means one screw wouldn't have been enough to keep the top from popping off, but this means that you only need one screw to keep it in place because you're just keeping it from rotating. So that's clever, very cute. And clearly this back piece is replaceable. I've seen these with other grill designs. I'm sure you can have the factory customize it for you. If you'd like a different design, you can put your logo in there. And you can also buy these with really no branding at all. So that's another option. I'm actually surprised by this branding is pretty professional looking, given how much less this is selling for than its competition. So all these screws, these are like self-tapping plastic screws. They're all the same length. I'm just putting them back in here in arbitrary order. And this is a kind of narrow well, so I'm going to use a small screwdriver to tighten these in. All right, so I think there were no surprises in here, actually. This is a pretty well-made product, and it seems to live up to its marketing claims, which I was not expecting, certainly not at such a lower price point. And I am actually very dubious that the HyperVolt is any different internally. I suppose these things could look cosmetically similar and have slightly different, rated components, but by the looks of it, they're all making the same claims, same frequency, same battery life, they come with the same attachments, and they all seem to come in the same case with a different logo on the outside. So I think that the variance is in the details, like the trim package, and the core product really doesn't seem like it changes. So the moral of the story is sometimes maybe you can get a deal if you're willing to go off brand, but certainly when you're comparing them, be careful to look at the mold markings, the sort of intrinsic properties of the way this was constructed to make sure it's actually the same product. There are some of these that look slightly different in form factor, and I suspect they're very different on the inside. So this is the sort of, this screw just keeps spinning. I don't know if it's tight. This is the sort of category of these cross-shaped versions of the massage gun. Okay, so we're almost ready to turn it back on. I'm gonna put these rubber gaskets in at the very end. I don't have to do that on the video, so we can move on. So let's put the battery back in. It is slightly asymmetric. There's a little bump on one side that keys into the case, so you can only insert it one way. It doesn't feel as directionally keyed as like a power tool battery, so it's a little fiddly to get it, like even though it's aligned correctly right now, I'm putting a good amount of force on it to get it lined up, and it's actually a little bit maybe over-constrained from how it needs to be. So you give it a good push, it locks in, and this tab, again, doesn't feel great, but it does release the battery like they say it will. So there's a switch on the bottom that turns on the battery, and then the product has power as evidenced by the lights on the back. And these LEDs are not diffused at all. They have the water clear lens on them. They're extremely bright. They actually kind of work as a flashlight. So a little bit of an odd choice of LED, but it's fine for this. Here's one of the attachments. This is the ball end. It has a little rubber gasket on it to hold it in here. They will fly off potentially if you don't press them in all the way, or you're not using this against like your body to massage something. Like if you just operate it in free air, the attachment might wiggle loose, but hasn't really been a problem in using it. So let's turn it on, and see how it runs. So it's very quiet. They all sort of compete on the sound level ratings. This one claims, I think, something like 30 decibels. I haven't measured the sound pressure level, but it's quiet enough that it's not bothersome. And this is on the low setting. You can see the blue LEDs illuminate, all the LEDs illuminate from right to left, which is a little bit unusual. And kind of made me think this was from market with right to left writing or something. Like it's very unusual to see products with indicators that illuminate from right to left, but that's how this one's designed. They say to charge it when the battery indicator gets down to red, so this one maybe has about half capacity left. If you press the power button again, it ramps up, and then one more time, it goes up to max, and then it turns off. So luckily, it went back together, no problems. Again, there was no weird adhesive in here, and I like the metal linkage. It seems like it has a brushless motor, like they promised. Has a big battery. This battery is very heavy, and I'd love to open it and take a look inside in a future video because it has the promise of big 18650 battery cells that we could use for another project. You could even probably mount this battery if you can find the receptacle in personal projects that need a beefy battery pack, because this has its integrated charge port, integrated status light, and integrated power switch, which is pretty awesome, and it has a grippy handle. So maybe we could do some DIY with this battery in a future project. Since they're used for all of these massage guns, it seems like they're widely available. So this is the Apollo Kinetics version of the massage gun. I suspect that it's, from what I can tell, exactly the same as the HyperVolt. So I recommend doing a little comparison shopping. Look for these mold lines, these fastener positions, the battery release tab, obviously the signature battery with the light at the bottom, and generally the same kind of attachments. Carry bag will usually come with it, but don't sweat it if the grill or the logo are a little different. I think that these are probably, based on what I've seen, they're coming from maybe the same factory, all certainly based on the same design. And from the inside of this one, it does not seem like they've cheaped out on the construction of the powertrain. So I'm quite happy with it and saved a good amount of money. So thanks for watching.